Hi everybody, welcome to another video in Business Calculus section 10.1, the constant E and continuous compound interest. First, we define the constant E. So this is like pi is 3.14 something. E is a constant and it is defined as the limit of n goes to infinity of 1 plus 1 over n of that to the n power. Or if we rewrite n as 1 over s, if we write like that, then here we have 1 over s turned into s, and if n goes to infinity, if s go to 0, then n go to infinity. So equivalently we can write in that form. And approximately equal to this number, so about 2.71828, that much. On the calculator, either we gonna say we hit e to the first power, that much, or we say second and the division, that also, that is the E. Right, now compound interest. Let P be the principal of a loan or of an investment. Let R be the annual interest rate where interest is compounded n times a year. So this is like business math. You should see this before. And the future values of A is given by this. So whatever we invest, we will get that amount 8 after t years, and the interest rates are, and n is the number of compounding period a year. Now, as n go to infinity, we will have this formula, and this is the proof. Right. So we have that compound interest formula that take n goes to infinity. The P is a constant. We can bring it outside. That's what we have here. Now, here the power of nt, and here we have n over r divided by r. So if we cancel out the r and the r, we're left with nt. So that's what we do. And then of course we take the constant p outside. Now when we see this, if we let s equal to r over n, if we let s equal to r over n, of course the r over n here is going to be equal to s, right? If we let s equal to r over n. Now this is n over r, so the n over r here, that is 1 over s. So that's why we have the limit as s go to 0, simply because if n goes to infinity, r is a constant divided by finite, a finite divided by infinity is equal to 0. So that's why s go to 0. And now, from here to there, the properties that we use is, if we have something raised to the m times n, it is equal to b to the m raised to the n power, right? So we have 1 over s times rt and to the rt, and finally this by definition is e inside the bracket here is equal to e. So we have p times e to the rt, right? So that's why this is continuously compound interest is given by future values equal to p times e to the rt, right? Now we have some exercise. Now let's just get familiar with the formula and how do we use it. So the formula is future values principal e to the rt. Now if $100 is invested, so that will be the principal. 6%, that's the rate. And we should write this as decimal. What amount will be in account after 2 years? So t equal to 2 years. Right, substitute everything in the formula. Future values equal to principal interest rate in 2 years. Right, and multiply that, we have e to the 0.12. Okay, the rest we just need put this in the calculator. So we can have 100 times e to the power of, we can just type like that. So that's 112. This is money, so let's round to the nearest pennies. Right. Oh, simple enough, right? Right, let's look at a couple more examples. How long will it take an investment of $5,000 to grow to $8,000 if it is invested at 5% compounded continuously? Right. Once again, we start with the formula. Right. We have the investment or the principal of 5,000 and grow to 8,000. So that will be the future values. And it is invested at 5%. We write 0.05. Right. And the question is how long? That means asking for time. Right. We put everything we know in the formula. We have 8,000 with 5,000. E, the rate 0.05 times t. We don't know t, but that's fine. We solve for it. Right. So, in order to solve for it, we should get the exponential term by itself. So we go ahead and divide 5,000 on both sides. Right, so we just have a divided by 5, 1.6. So we have 1.6 equal to e times 0.05 t. You should see this type of equation in business math, the previous part of the class before business calculus. To solve for something on the exponent, we need to take the ln on both sides. And we take advantage of the exponential function and logarithmic function, the natural log, are inverse of each other. So that is, if we have ln of e to the m, for example, something like that, ln of e cancel out, we just have m. So to get rid of the e, we will take the ln on both sides. That's the natural log. Right. Now either here we can just bring the exponent outside. Of course, we'll review the properties of logarithms in the next section. But in general, if we have something like this, we can take the exponent m outside. That's what we have. And put them together. ln and e will cancel out. So pretty much when we have that, it's just ln and e cancel out in that form. So we will have ln of 1.6 equal to 0.05 times t, and so we just solve for t by divide by 0.05 on both sides. So we have t equal to ln 1.6 divided by 0.05. So this is ln 1.6 divided by 0.05, and that's what we have, 9.4, and this is t, so in years. Right. Once again, if we want to solve for the variable in the exponent, we need to get the exponential term by itself, and then take in ln or the natural log on both sides. Ln and e cancel out, and we can just solve for the variable on the exponent. Right. Let's look at this example. How long will it take? So once again, it asks for time. It takes to the money to double its values if it's invested at 7% compounded continuously. Right? Compounded continuously. That A equal to P ERT. Alright. Now we don't have much information other than the rate is 7%. The only thing we have is double. So double whatever we invested. So if we invested P dollars, P amount, so the principal, then the future values is going to be twice the principal, and that will be enough for us to solve our problem. Now substitute everything here. We have 2p, that the future values twice the principal, and then e, we know the rate, and t. Right. Now once again, we need to get the exponential term by itself, so we divide by p. So that's why in this problem doesn't matter what the investment is, it cancels out, and the equation does not depend on p. Now what we try to solve for is t. So to get the exponent, the variable on the exponent, we'll take ln on both sides, because ln of e is 1, or they cancel out. So that cancel out, and we have ln of 2 equal to e times 0.07. I'm sorry, ln of e cancel out, so we just have 0.07 times t. And then we divide by 2, 0.07 to get t by itself. So we have t equal to ln of 2 times 0.07, and this is just ln of 2 divided by 0.07. It's about 9.9, so that's about 10 years. Right. By the way, if here we use the properties in general, let me write this again. So we have ln of e 0.07t. There's a properties that allow us to bring the exponent outside like this. So we have 0.07 times t times ln of e, and ln of e is equal to 1. So this equal to 0.07 t. So they, as if it is ln of e cancel out, and we can say ln of e is 1, right? So either way, ln and e cancel out, and we have the variable on the exponent, and we solve for that, right? So I just want to write out, just want to discuss one more thing. So take 10 years to double an investment, given that it is 7% compounded continuously. Now, if we want to double that amount again, it's going to take another 10 years. So for example, if we have $100, right? So in 10 years, we will double that. I mean, roughly. That's 9.9, but let's say exactly 10 years. In another 10 years, that will be 400. And in another 10 years, that will be 800. So every 10 years it will double. So that's why in this problem it doesn't matter what we have from the beginning, the principal. The more we have, it's going to be double that amount in 10 years. Right. So that's the first point I try to make. The second point, the first point is it doesn't matter what the investment is. It's going to take 10 years to double that amount, given the compound interest rate is 7%. Right. Yeah. So this is continuously compound interest. If it is just compound interest, then it is an approximation. It's still about 10 years. Right. So there is a rule in business. It said the rule of 70. It says that the time to double an investment is equal to 70 divided by the rate. So, I mean, approximately equal to, not exactly. So in our example, we have 70% divided by 7. So 70 divided by 7, so 10 years. And you say, where's that coming from? Well, if we have ln of 2, that is 0.693, right? Now if we write it down, the answer, exact answer is ln of 2 divided by the rate, in this case 0.07, right? Now ln of 2 is 0.693 and 0.07. Now if we multiply 100 top and the bottom, just move the decimal place, decimal point 2 places to the right, and that gives us 69.3 divided by 0.0 divided by 7. Now what you see, 69.3 is very close to 70. So that's what this rule is for. So the time to double an investment is 70 divided by the rate. The rate is not in decimal, the rate just whatever it is, like 7%, we're going to take the 7. So if it is like the interest rate is 10%, the time to double an investment would be 70 divided by 10. That would be 7 years. And that's all I want to go over in this section. In the next section, we'll study about the derivative and derivative of the exponential function and logarithmic function. Thank you for watching. See you in another video in business calculus.